Good morning, guys. So let me review from the last class. I think we discussed about the function, right? And we also talked about relation. So a relation is a set of ordered pairs. We did that, right? And a function is a relation in which for each distinct value of the first component, right? For each distinct value of the first component of the ordered pairs, there is exactly one value of the second component. So this is the definition of the what function, right? That makes sense? So you see, if you look at these ordered pairs, what do you think? Is this is this relation a function? Does this relation define a function? So for each x value, is there exactly one y value? What do you think? Yes? Is this a function? Okay. You see, the relation f is a function because for each different x value, there is exactly one y value, and you can see that. Right? Okay. So now, what about this? If in the set of ordered pairs, x values are repeated, right, then it cannot be a function. You see, you have x value 1 and this x value 1 paired with what? Y value 1, 2, and 3. You see what I'm talking, right? So you have G is the set of ordered pairs. You have 1, 1, 1, 2, 1, 3, and you have 2, 3. Right? So now you see the x values are repeated here, these x values. So x values 1, it corresponds with 1, it also corresponds with 2, and it also corresponds with what? 3. That makes sense? And then you have a 2, it corresponds with 3. Now you see this x value 1, right, for the x value 1, there are 3 values of y. Is that right? So that's why this is not a function. That makes sense? A function is a relation in which for each distinct x value of the what? Ordered pair, there is exactly one y value. Right? But in this relation, for x value 1, you have what? 3y value. So that's why this is not a function. Every function is a relation, but every relation is not a function. May not be a function. You know what I mean, right? Okay? What about this? What do you think? Does this relation define a function? Yes. Look at in the state of ordered pairs. If you have x values repeated, right? If -2 is repeated, right? So this is not a function because -2 is paired with 2y value. That makes sense? Right? So this is a mapping diagram, you guys know that, right? And this like so if the x value is considered as input, an x variable is called independent variable. The y variable is considered as output and y is dependent variable. The value of y depend upon the value of x. Make sense? And the next one is the domain and range. Domain is the set of all x values, or you can say set of values of the independent variable. You can say that. If you have an ordered pair x comma y, right, the set of all x values of the independent variable x is the domain, and set of all y values, the set of all the dependent variables, all values of the dependent variable is range. So now, if you look here, this is a relation, right? In this relation, what will be the domain? What is the domain? One. You see, you list all x values, right? The values of all independent variable. So 1, 2. That makes sense? And what is the range?
1, 2, 3.
Yes, the range is set of all y values. And the y value, y is what? Dependent variable, right? Set of all values of dependent variable. Make sense? So now this range is going to be 1, 2, 3. Look here. So what is the domain? So what is the domain and range of this relation? What will be the domain?
3, 4, 6.
Yes, 3, 4, 6. And what will be the range?
-1, 2, 5, 8.
Yes. Yep, that's right. And what do you think? Is this a function? Why?
4 has 2 outputs.
Yes. This is not a function because 4, right, has 2 output. Right? Good job. What do you think? Is this a function? What is the domain?
4, 6, 7, 8.
Yes, the domain is 4, 6, 7, -3. And what will be the range?
100, 200,
Yes. So range will be 100, 200, 300. Right? And does this relation define a function? Yes. Right? Because every x value, distinct x value, has exactly one y value, right? Right? Okay. What do you think? Is this a function? This is the function. This is the relation given in a table. So that means -5 correspond with 2, 0 correspond with 2, and +5 correspond with 2. What do you think? Is this a function? Yes, this is a function, right? And then what will be the domain?
-5, comma 0, comma 5.
Yes, domain is set of all x values. -5, comma 0, comma 5. And what is the range? Yeah, this is a constant function because the y value is constant. You see that? That makes sense? Are you guys with me? Good job. So, what is the domain and range of this relation? What is the domain? Did you see that?
We'll do 1, comma, -1, comma 0, comma 4.
Yes.
Domain.
Yes. So you have the ordered pairs, -1, comma 1, right? 0, comma -1. You see that, right? So -1, comma 1, it's on the third quadrant, right? And then 0, comma -1, you have 1, comma 2, and 4, comma -3, right? So the domain is the set of x values. So -1, comma 0, comma 1, comma 4. And what will be the range? Yes. Range will be -3, comma -1, comma 1, comma 2. You see that? It's pretty simple, right? Good job, guys. And what do you think? Is this relation a function? Yes? For each x value, is there distinct y value? Sorry, is there exactly one y value? I'm sorry. For each x value, right, does distinct x value correspond with exactly one y value? Yes? Okay. So this is a function, right? Hey, what is the domain and range of this relation? You know the
-4, comma 4.
yes. You say like the domain is the set of x values, right? So let me draw this graph here. I mean like so you have this. You have this. So this is +4. This is -4. This is +6. And this is what? -6. Okay? So it's something like this, okay? Are you guys with me? It's something like this, okay? I mean, like, it's not that much good, but let me try to make better. It's not easy. So you have it. It's something, I don't know. Something like, but you understand what I mean, right? So this says 4, this says -4, is that right? And this is +6, this is -6. Now, remember, domain is the set of x values. So this is +4 and this is -4, okay guys? So domain is the set of x values. Yeah, but that's partially correct. So look here. So for -4, what is your y value?
0.
Yes. This is -4, 0, right? Right? Now, if you look here, for every value, like this is negative 3, is that right? For negative 3, what is your y value? Is that 4? Is that right? So what I'm going to, you see that, right? It has a 2y value, you see that? See, if you have a negative 3, it has this y value, which is positive 4. For negative 3, you have this y value, which is what? Negative 4. Did you see that? Now I'll show you, okay? You'll get it. So now look here. So for every x value here, look here. If you consider this side the x value, you have a y value here, and you have a y value here. Did you see that? Right? If you have an x value here, you have a y value. It corresponds with y value here, as well as the y value here. You see that? You see that? Right? So if you have x value here, it corresponds with what? This y value, and it also corresponds with what? This y value. Did you see that? So what I'm trying to tell you is, hey, for every x values between negative 4 and positive 4 inclusive, right? For every x values here, right? There are 2 y values. You see that? Like if you consider x values here, what are the y values? You have a y value right here, and you have a y value right here. Did you see that?
It's like if this wasn't a question we had to answer, we would do it like that, like negative 4, 0, negative 3, 4, negative 4. Do you know what I mean?
Yeah.
So we would write it down like that?
We cannot list all of them. You see what I'm talking? Like, let's say you are right. You said like, hey, negative 4 correspond with 0. This is one order pair. But right next to the negative 4, what do you have?
Negative 3.
What about negative 3.99?
Okay.
You see what I'm talking?
Yes, sir.
This is the x value, right? or what about, like, let's say this is y value, we don't know. Let's say, what about negative 3.999? This is another one, right? So how many values between negative 4 and positive 4 here? Infinitely many. You see what I'm talking about? But for every x values between negative 4 and positive 4 inclusive, right, we have a y value. Some of them has 2 y value, except negative 4 and positive 4, right? Every x values between negative 4 and positive 4, for every x values between negative 4 and positive 4, we have what? 2 y values. Agree? Look here, if you consider x value 0, your y value is what? 6 as well as what? Negative 6. Did you see that? Right? So that's why the domain is, you know, the definition of the domain is set of all x values. Right? So you cannot list all of them, but you can write that in an interval notation. Any values between negative 4 and positive 4 inclusive, including negative 4 and positive 4, you can write negative 4 is less or equal to x is less or equal to what? Positive 4. Did you see that? So this is the domain.
So when you're writing in interval notation, you just write it as negative 4, 4.
Exactly. If you write in an interval notation, if you want to write in an interval notation, so it's going to be negative 4, 4, but you see, this is a non-strict inequality, right? So what do you put here? Parenthesis or bracket? Bracket. You got it. So this is the domain, guys. Did you see that? Because domain is the state of x value, right? Make sense? What will be the range? Yes, negative 6, 6, but that's the interval. You know what I mean? Yeah, because look here, for every x values here, you have a y value right here. Oh, let's see. You have a y value right here. For here, you have a y value. For this, you have a y value here. You see? Are you with me, guys? Huh? Did you see that? What I'm talking about? Yes? For every x value, let's say you have a x value here, and where is the y value? The y value is, it goes here, this is the corresponding, this is the corresponding y value, and it goes down, and this is the what? Corresponding y value. Did you see that? For every x values, right, we have y values, right, between -6 and +6 inclusive. That makes sense? So the range is -6 is less or equal to y is less or equal to positive y. You see what I'm talking, right? Right? Sorry. This is +6. Is that right? Yes. Or you can write this in the interval notation. So this is -6, comma 6. You see what I'm talking? You have this, and you have this. So this is your -4, this is your +4, this is your -6, this is +6. Now for every x value, if you have x value here, you have a corresponding y value here and here. If you have x value here, you have a corresponding y value here and here. If you have a y value here, you have a corresponding x value here and here. Did you see that, guys, right? So all the y values are what? Here. Make sense? So -6, comma +6. Okay. Got it? Now what do you think? What is the domain and range of this relation? Hey, by the way, hey, is this a function? Does this relation define a function? No. Why?
X has two different.
Exactly. You see, just look here. If the value of x is 0, right, then it corresponds with what? Two different y values, right? +6 and -6, right? That makes sense? Look here. So what is the domain and what is the range? And this is arrow, okay? So that means you can extend this infinitely in this direction, and you can extend this. This is the arrow. You know what I mean? You know what that means, right? So what do you think? What is the domain and what is the range? What are the x values and what are the y values? So you look at the whiteboard, okay? So let me draw this graph over here. Excuse me. Okay? So if you look at here, so you see, so this is your x-axis, this is your y-axis, is that right? So, and this is the graph. And I can see here this is 1, 0, it passes through, this is 1, 0, and this is 0, 1. So now look here, guys, so for, you are trying to find out the domain. Domain is the what? Set of all x values. Like, look here, for this point here, your x value is here. Are you with me? Right? Your x value here. If you consider the point here, your x value is here. If you consider the point here, your x value is here. If you consider point here, your x value is here. If you consider x value here, if you consider this point, your x value here. If you consider this point, your x value is right here. And if you consider this point, your x value is here. If you consider this point, where is the x value of this point? Here. If you consider this point, your x value is right here. If you consider this point, your x value is right here. Are you with me? So every x value is here. You know what I mean? Every point on the x-axis is the element of the domain, or is in the domain. Did you get it? So and you see, this is the arrow, so that means you can extend infinitely in this direction, and you can extend in both directions infinitely. That makes sense? So if you consider this point over here, hey, where is the x value? X value is what? Right here.
So it would be negative infinity,
Exactly. Yes, negative infinity, positive infinity. Or every point on the x-axis is in the domain. The set of all real numbers is the domain. That makes sense?
So if it is negative infinity, infinity, wouldn't that technically mean it's not a function?
No, the function means for every x value in the domain, right, there is exactly one value in the what? Range. Or each distinct x value corresponds with exactly one y value. So now, this x value here, it corresponds with exactly one y value, which is right here. I will show you here. So if you consider this x value, it corresponds with y value here. Is that right? So it corresponds with only one y value, right? If you consider x value here, if you consider x value here, here, it corresponds with what? It corresponds with y value, unique y value here. So every x value here corresponds with exactly one y value. Is that right? So that's why this is a function. That makes sense? So now the domain is, you can write negative infinity, positive infinity, or you can say set of all real numbers, right? This is same as the set of, you can say just all real numbers. All real numbers. And range is what? What will be the range? Range is set of all y values, right? Right? If you have a point x value here, this point has the y 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 value here, right? Every point on the line has y value on the y-axis. Is that right? So what will be the range? Yes. So this is also negative infinity, positive infinity. So this is all real numbers. Did I make sense? Look here. Yeah. Right? The arrowheads indicate that the line extends indefinitely left and right as well as up and down. Therefore, both the domain and range include all real numbers. What about this? What will be the domain and what will be the range? Do you know that? Yes, so you see the arrow here on the left and right. So that means you can extend the line indefinitely up. Right? And left and right also. But you cannot the graph is above certain line. So you cannot go below that line. So I'll show you here, okay? So you have this, right? This is your x-axis, and this is your what? Y-axis. So you can write x and y. You don't have to write this. So y, and you have a graph. So it's a -1, -2, -3. So this is -3. This is -3. And does it pass through the origin? Looks like that, right? 2.5. So you do have something like this, guys. You do have something like this. See that? Right? So now this is, look here. So your y value, it cannot go below what? -3. But you can extend the graphs indefinitely, left, right, and up. That makes sense? So you can do that. It goes like this. You can do that indefinitely.
So for like, we're trying to write that down would be for the domain, negative infinity, comma, infinity. And for the range, it'd be -3, comma, infinity.
Yes. Yes. Because domain is the set of x values. Like if you consider x value here, if you consider x value, if you consider a point here, your x value is here. If you consider a point here, your x value is here. Right? Are you guys with me? If you consider a point here, your x value is here. If you consider a point here, x values here, you see what I'm talking, right? Right? So you see every point on the x-axis is in the what? Domain. So that means your domain is all real numbers. Negative infinity, comma positive infinity. But your y value, it cannot go below -3.
So would it be bracket -3?
But it can be -3.
Yeah.
Oh yeah, you are right. Bracket negative. Yeah.
-3, comma, infinity.
Yes, that's right. So your range is going to be bracket -3. You see what I'm talking, right? Because for this point your y value is here, for this point your y value is here, for this point your y value is here, for this point, right? For this point your y value is here, for this point your y value is here, for this point your y value is here, for this point your y value is here. Is that right? Make sense? So -3, comma, it go all the way up, positive infinity. So that will be range, right? Y is greater or equal to -3. Make sense? Okay. Did you get it? Good. So now, you see, like when we talk about the domain, unless it's specified otherwise, we assume the domains are what? Real numbers. You know what I mean? So, and then when you, the range, when your input is real numbers, their output is also what? Real numbers, right? Okay. Now the vertical line test. If every vertical line intersects the graph of a relation in no more than one point, then the relation is a function. If a vertical line intersects the graph of a relation exactly once, then the relation is a function. Did you get it? Now look here. So you have to use the vertical line test. For this, let me go back here. Okay, I think it's it. Look here. So this is the relation, is that right? So you draw the vertical line. So at how many points the vertical line intersects the graph here? Only one? If you draw the vertical line through -1, 1, it only intersects -1, 1 point, right? So that's why this relation is a function. You see what I'm talking? Look here. You draw the vertical line. At how many points does the vertical line intersects the graph? 2 points. Are you guys with me? You see what I'm talking, right? Look here. So what I'm saying is, hey, we have this graph here, right? And then if you draw the vertical line, here, you see the vertical line intersects the graph at 2 points. So that's why this is not a function. You see the vertical line here? It intersects at 2 points here and here. So that's why this is not a function. You got it? Now, for the next one, look here. If you draw a vertical line, right? If you draw vertical lines, every vertical line intersect this graph in no more than 1 point, right? Right? If you draw the vertical line intersects the graph exactly once. Is that right? So that's why this is this a function? Yes. What about this? You draw a vertical line, right? Vertical line intersects the graph exactly once. You see that, right? Right? Look here. You have a graph like this. Let's draw a vertical line. This. At how many points does it intersect? Only 1 point. See that? This. How many points? 1. This. How many points? 1. You see that? So every vertical line intersects the graph exactly once. So that's why this is a function. This relation is a function. Make sense? Yeah, that's what the vertical line. This is a function, right? Because the vertical line intersects the graph no more than once. Okay, this is not a function, right? This is a function. This is a function, right? Okay. So now, what do you think? Decide whether each relation defines y as a function of x, give the domain and range. So this is your relation, right? Y equal to x plus 4. So you have a relation y equal to x plus 4. Is y equal to x plus 4 a function? So what is the answer? Now, when you plug in some values of x, right, does it produce 2 values of y? Or more than 1 value of y? You just like to think, like, hey, you come up with values of x, you plug in there, right? Does it produce 2 values of y or more than 1 value of y? No, right? You see what I'm talking? So that's why for every x value, there is exactly 1 y value, right? Right? So that's why this is the answer is yes. Or you can think in this way, hey, if you draw, this is a linear function, you know that, right? If you draw the graph, so let's say make a table here for the x value and y value. If I plug in x equal to 0, what is the y value? 4. So this is y-intercept, right? If you plug in y equal to 0, what will be the value of x? -4. And if you draw the graph, you can see here, so 0, 4 is somewhere here. So this is 0, 4, and -4, 0 is somewhere here, right? And if you draw the graph, oops, sorry. So it's something like this. Are you guys with me? Now use the vertical line test. Vertical line intersect graph no more than once, right? So that means this is a function. Does that make sense? Yeah. Right? Okay. So now look here. Oh, okay. In the defining equation or rule, y is always found by adding 4 to x. Thus, for each value of x correspond to just one value of y. Okay, and the relation defines a function. And what is the domain? The domain is what? Look here. The domain is, you can come up with, yeah, -∞, positive infinity. Is that right? And the range is also -∞, positive infinity. That makes sense? You can plug in any value of x here, and that will give you what? One value of y. Is that right? So this is a function, and the domain is the state of x values. So you can consider any values of y, right? Sorry, any values of x. That makes sense? And when you plug in the value of x, that will produce unique value of y. Are you guys with me? The domain is -∞, positive infinity. For this function, y equal to x plus 4, domain is -∞, positive infinity, and range is also what? -∞, positive infinity. What about this? Decide whether each relation define a function. So you have a relation y equal to is y equal to radical 2x minus 1 a function. Just think in this way, okay? Hey, do we have a value of x when you plug in there, right? Gives you more than one value of y. Can you come up with a x value when you plug in produce more than one y value? Do we have such x values? Do we have such x values when you plug in here give you more than one y value? We do not have that x value, right? So when you plug in x value here, you always come up with the what? Exactly one y value. Right? You see what I'm talking? Let's say, hey, I want to plug in x equal to what? What do you want to plug in here? Just give me the value of x. 2. So what will be the y value? 2 times 2 minus 1, what do you add? Radical 3. You see, for 2, it corresponds with only one y value, what? Radical 3. That makes sense? So you can think any x value. But keep in mind, the range must be a what? Real number. Like I cannot plug in, let's say, hey, I cannot plug in x equal to 0. X equal to 0 is not in the domain, because when I plug in x equal to 0 here, you see this is 2 times 0 minus 1, right? So this y equal to what? Radical -1. You see that? So this is not a real number.
So if that would have been a 2 times 0 plus 1, you'd be able to do x equals 0?
Yes.
All right.
Yes. You see, now to find the domain for this type of radical function, we use this method, because you know the y is a real number, because the range must be a what? Real number, is that right? Right? So look at the value under the radical sign. We call radicand. This radicand is 2x minus 1. You see that? So this must be either 0 or positive. So 2x minus 1, it must be 0 or positive. Does that make sense? If 2x minus 1 is negative, then the square root of negative is not a real number. So you see the 2x minus 1 is greater or equal to 0. Right? So you add 1 on both sides. You cross them out. So that will give you 2x is greater or equal to what? 1. Make sense? So you divide both sides by 2. And that will give you x is what? Greater or equal to? Greater or equal to 1/2. Make sense? So every value of x greater than or equal to 1/2 is in the domain. Okay? So your domain is going to be x is greater or equal to 1/2. If you write in the interval notation, it's going to be bracket negative 1/2 comma positive infinity. So this is the domain. Now what will be the range? And remember that square root of any number is always is a non-negative, right? You know that, right? Square root of a number, this is the square root of 2x minus 1. Y is a square root of a radical 2x minus 1. You know that, right? So a square root of any number is a what? Non-negative number. It cannot be negative. So the y value must be greater or equal to 0. You see what I'm talking? So now the range is, you say y greater or equal to 0. Because y is what? The square root of 2x minus 1, right? If you take a square root of some number, it cannot be what? Negative. It is either 0 or positive. So that's why the range is going to be, if you want to write in an interval notation, it's going to be 0 comma positive infinity. Did you get it? Okay, so yeah. Now what do you think? Does y square equal to x, this is a relation, okay? Does y square equal to x, does the relation, okay, let me write down here like this. Does the relation y square equal to x define a function? What do you think? You just like you think, you come up with the value of x, okay? When you plug in, if that value of x give you two values of y, or more than one value of y, then it cannot be a what? Function. So do you have values of x when you plug in here gives you two values of y? Did you understand my questions? Can you come up with a value of x when you plug in here produce two values of y? Think about it. Did you get it? Think. Give me the value of x. When I plug in here, produce two values of y. No? You didn't get the values of x? Give me just one value of x. Give me x. Okay, what do you want to pick? Give me. 9. So you plug in there. Y squared equal to 9, right? What are the values of y? 3? Huh? Plus or minus what? You remember the square root property? Long time ago we talked about that. Square root property. If x squared equal to k, right? Then x equal to plus or minus radical k. So now if y squared equal to 9, then y equal to plus or minus 9. So this is plus or minus 3. So now if I plug in x equal to 9, it corresponds with positive 3. It also corresponds with what? Negative 3. Is that right? Right? Did you say that? It corresponds with negative 3 and positive 3. And now is this a function? Does this relation define a function? Exactly. That makes sense? Now this is not a function. But what is the domain and range of this function? What x values you can pick from here so that y is a real number? You see what I'm talking, right? So what do you think? Yeah. It cannot be any value of x. You know why? Because let's say, for example, what do you want? Let's say you want to pick like x equal to negative 1, for example, right? So what will happen? Y square, now y square equal to negative 1, so y equal to plus or minus radical negative 1. So you know this is radical negative 1 is I. So this is not a real number, right? So think in this way. Hey, this is y square, right? A square of any number must be what? Positive. That makes sense? Right? So this x must be positive. You know what I mean? Because x is the square of y. So x can be 0 or positive. Sorry, x cannot be negative, okay? It should be non-negative. Non-negative means it can be 0 or it can be greater than 0. That makes sense? So now, let me say that again. X is the square of y. So that means x must be what? Non-negative. Non-negative means greater or equal to 0. Is that right? The domain is the set of values of x, right? So now, what will be the domain? So what will be the domain here? Yes. 0, infinity. Now, if you want to find the value of y, how do you find the value of y? What will be the range? What do you think? Is this negative infinity comma infinity or 0 comma infinity? Negative infinity comma infinity. Exactly. Yeah. Because You see, the y can be positive or negative. You know what I mean? Because if you positive is squared, that will give you positive. If it is negative squared, it also give you the what? Positive. That makes sense? So now the range is all real numbers. So this is negative infinity, comma positive infinity. Yeah. Yep. Did you get it? What about this? Decide whether each relation defines a function. What about this? Oh, why did I do that? So does the relation y equal to lesser equal to, y is less than or equal to x minus 1 define a function? What do you think? Do you know how to draw the graph for this? Y is less than or equal to x minus 1? So first, what is the corresponding equation? Y equal to x plus 1, right? You find out the corresponding equation. Yes, sir. The corresponding equation is this, and you know how to draw the graph for this equation, right? Right? We find out the x-intercept and y-intercept. That's the easiest way, right? So if I plug in x equal to 0, what will be the value of y? 1. If I plug in y equal to 0, what will be the value of x? Negative 1. So now if I plot them, so this is x-axis, this is y-axis, right? So 0, 1 is right here. Let's say this is 0, 1. Excuse me. And this is negative 1, 0. So this is negative 1, 0. So now you join them again. This is the line, right? Right? But you see, now this line divides the plane into 2 equal halves. So that is the inequality. Y is less or equal to x minus 1. You see, the first, I found the corresponding equation, which is y equal to x plus 1. Then I graph y equal to x plus 1. This is the line, is that right? And now this line divides the plane into 2 equal halves. This is the upper half plane. Did you see that? This line divides the plane into 2 parts, upper half and lower half. So this is upper half plane, and this is what? This is lower half plane. Does that make sense? So now, hey, which one is the solution set? We don't know that, right? Either upper half plane, it should be either upper half plane or lower half plane, but we don't know that, right? So now, hey, let's take a testing point. Let's say 0, 0 is this is origin, right? So lower half plane contain origin, is that right? If I plug in 0, 0 here, and if that point satisfies this inequality, lower half plane will be a solution set. Otherwise, upper half plane will be the solution set. So, are you with me? I'm going to take testing point. Let's say the testing point is 0, 0, which is on the what? Lower half plane. So now you plug in 0, 0, so you have y is less or equal to x minus 1. You plug in 0, y equal to 0, x equal to 0. So 0 is less than or equal to 0 minus 1. Are you with me? And that will give you 0 is less than or equal to negative 1. Is this true or false? Is 0 less than negative 1? This is false. Is that right? This is false. Are you with me? So that means lower half plane cannot be a solution set. So what is the solution set? Upper half plane. This. This is the solution set. Are you guys with me? This region is the what? Solution set. Are you with me, guys? right? So now, tell me, hey, if I draw the vertical line, so any point in this region, any point, this, any point, how many points here, guys? Infinitely many points satisfy that inequality, is that right? And you know the vertical line test, right? If I draw the vertical line here, hey, if I draw the vertical line here, at how many points vertical line intersects? Infinitely many points, because these are the solution, you know what I mean? Right?
It's an inequality with the line.
Yeah, this is not a line. The solution for this inequality is all the points here in this plane, is that right? So exactly. So now if you have a solution here, look here, you have a solution here for that inequality, you have a solution here, you have a so that inequality is the what? Collection of all these points, is that right? You see what I'm talking? How many order pair here, guys? How many order pair here? Infinitely many, is that right? And if you draw the vertical line passes through what? Infinitely many order pairs. Is that right? So that's why this is not a function. Make sense? This is not a function. You see that? Okay, so now, this relation, you can look here, yeah. So you see that, right? So if I have x equal to negative whatever, -1, you know, like how many values here? 1, -1, -1, -1, -2, -1, -3, -1, -4, -1, -5. You see that? So this is not a function. And now, hey, if you want to find the domain and range, domain is the state of what? Values of x, and range is the state of values of y, right? So now look here. So what will be the domain and what will be the range? So if you look at this, all these regions are the solution set, right? So right? So domain is the state of values of x. So look here. Domain is the set of values of x. So look here. So if I pick a point from here, where is the x value? Right here. Right? If I pick a point from here, what will be the x value? Right here. Are you guys with me? If I pick a point from here, where is the x value? Right here. If I pick a point from here, where is the x value? Right here. If I pick a point from here, where is the x value? Right here. So what is the domain? Set of all real numbers. Is that right? Right? So domain is set of all real numbers, which is negative infinity, positive infinity. And what about range? Range is the set of y value, right? So now you see for this point you have a y value here. See that? See that? For this point you have a y value here. Look here. So for this point you have a y value here. Now for this point, this is also the solution, right? Where is the y value? So your y value is you know, where is that is? So this is the vertical line, right? So for this point you have y value here. For this point you have y value here. Not here, okay. For this point you have y value here. This is y-axis. This is y-axis. For this point you have y value here. You see that? So range is also negative infinity, positive infinity. Okay? What do you think? Is this a function? So do we have value of x when you plug in that relation produce two values of y? Does the relation y equal to 5 over x minus 1 define a function? can you come up? Do you have value of x when you plug in here that will produce two value of y, two values of y? Do you? No, right? No. So if you plug in the value of x there, it always produces only one value of y. So that's why this is a function. So this relation defines a function, right? So what would be the domain and what will be the range? What will be the domain of this function? Domain is the set of values of x, right? Right? So is this relation, is this function is well defined, is this function is good for any values of x? Do you find, can you find value of x when you plug in here, this function will be undefined? Or what values of x make this function undefined? Yes, 1, right? If I plug in 1, what will happen? 5 over 1 minus 1, so that is 5 over 0, is that right? What is 5 over 0? 5 over 0 is, what is 5 over 1 minus 1, y equal to 5 over 0. What is this? This is undefined, right? 0 over 5 is 0. 5 over 0 is undefined. That makes sense? So you cannot include 1 in your domain, right? You cannot include 1 in your domain because when you plug in 1 here, it makes the denominator 0, and 5 over 0 is undefined. That makes sense? Or the easiest way to find that is, let me write down here. So you always, if you have, this is called a rational function. This is a rational function. You always set denominator equal to 0. So that will give you what? X equal to 1. If you do x minus 1 equal to 0, you to find out what values of x makes the denominator 0, you always set denominator equal to 0 and solve for x. Okay? I did here denominator x minus 1 equal to 0, and I solved for x, and what is the value of x? 1, right? So now you have to exclude this 1 from the domain. So now it is good for every value of x except 1. That makes sense? So we have to exclude 1 from the domain. So now look, make a hole here. This is the 1. You see that? We exclude 1 from the domain. That makes sense? Because 1 makes this function undefined. Okay? So now what will be the domain here? So that this domain is equals to, now can you tell me what will be the domain? You cannot include 1, okay? So I made a hole here. You see that? So it can be any number from negative infinity, comma 1. Is that right? But you cannot include 1, so you have to put parentheses. Union. Yes, union 1, comma positive infinity. This is the domain. That makes sense? And what about range? How do you find the range? The range is the set of y values, is that right? Right? So your y values, it cannot be what?
0,
0. but it can be negative. Like like only thing the y value, only number y cannot be is 0. Y cannot be 0.
So it'd be negative infinity, comma, 0, union, 0, comma, infinity?
Yeah.
Okay.
Yeah. So you are right. So you see what I'm talking, right? Because your y value, it can be every number, but except 0. You know what I mean? So you have a 0 here. Are you guys with me? Right? So it goes negative infinity all the way up to 0, union 0 to positive infinity. That makes sense? So now this is negative infinity, comma 0, union 0, comma positive infinity. Did you see that? Because it cannot be 0 because there are no values of x. You do not have values of x that produce y value 0. That makes sense? Okay. Yeah. So this is a function, right? And that is the domain and range. Did you understand that? Okay. So now we did, this is the definition, like we did that. Now function notation. Oh, do you want to? Okay, go ahead. Okay. Now look here, guys. The function notation, okay? So generally, if it is a function, we use, like hey, this is y equal to 5 over x minus 1. We know this is a function. Y equal to 5 over x minus 1 is a function. We know that, right? So generally, we use the notation this. Y equal to fx equal to 5 over x minus 1. This fx, this means y is a function of x. So what that means? This y equal to fx means, how you read that? Y is a function of x. This is the notation. Did you get it? That makes sense? Right? So if you have a, this relation defines a function. You know that y equal to x plus 1, right? So how do you write in a notation? You simply write down, hey, y is a function of x, so you can replace y by fx. If the relation is a function. This is a function, right? So you can write fx equal to what? X plus 1. Okay? So that's just the notation. Now, hey, look here, guys. So if you want to find out f2, you have a function fx equal to negative x squared. It's very simple, So you have fx equal to what? Negative x squared plus 5x minus 3. If you want to evaluate f2, so how do you evaluate? How do you find f2? How do you find f2? You plug in. In place of x, what do you have? 2. You plug in what? 2 here, right? Right? Plus this is 5 times 2 minus 3. Make sense? And this is f2 equals to, this is negative 4 plus 10 minus 3. So this is, what is that is? 3. Is that right? 10 minus 7, yeah, this is 3. Did that make sense here? Yeah, f2 equal to 3. Did you see that? Now if you want to find out fq, you replace x by q. Hey, I want to stop here. I will see you on Thursday. Okay, bye.